Okay, let's start. Good morning, everyone. We are having a new subject today, and that's about tokens. It's one of the things that Ethereum is famous for, of course, and a lot of money has been put into those tokens. And today we're going to see how they work exactly, and the assignment will also be that you're going to deploy those tokens. So and then you have to know how it works. We are going to talk about 3 tokens: the ERC20, the 721, and the 777. Does anybody know those numbers already? Yeah? What's the ERC20?
One of the first common standards for creating tokens.
Yeah, that's the first and most used probably standard. And then we have the 721. Who knows what that is?
They fixed the refund function. They implemented the start to refund the transaction if it's going to one contract or one address, which didn't support the token, I believe.
Yeah, they have a sort of security function, but they're different because they are for non-fungible. So that's for individual tokens. So all the tokens from this one are all the same. So you have 1 to a million tokens, and all those tokens are the same. And these are for tokens which are each different. So like for cards or whatever. So you can have an individual token which you can send to somebody else. And also security features. Anybody know the 777? Yeah, no, but that 777 is basically an extension of ERC20. So it's the same type of normal distributable tokens with some functionality that has been added to it. Let's dive into the ERC20 first. Okay, the tokens, this is just basically a smart contract. So if you see it, you will recognize it as any other smart contract you've seen so far. And of course, a smart contract is defined by the functions it has. So I've grouped the functions over here, and the ERC20 is actually a quite straightforward and simple contract. So it's amazing that in such a simple contract that so many millions of dollars have been put into the contract, and most of the time it has gone pretty well. Hey. So there's a group of functions here on the above that are used to get some information about the token. So you can get the token name, the token symbol, and the number of decimals, and the total amount of tokens there is. And this type of tokens is just like Ethereum, where you can have 0.00001 tokens, so like the Rai in Ethereum. So that's why you also have the 18 decimals. And when you create a contract, you can specify the number of decimals, but it's best to always keep that at 18 because most other software expect it to be 18. So just keep it simple at 18. Now then there are 2 functions. So that actually this is the main functionality. So you can transfer a token to somebody else, and you can see which address has how many tokens. So if you've actually implemented these 2 functions, you already have an ERC20 contract. which functions and which you can use with MetaMask to transfer tokens. So it's pretty straightforward. And they've added some extra functions over here. That's to actually delegate the token transfer, and that's to have exchanges or whatever who can transfer tokens on your behalf, where you can put your token up for sale and somebody else can buy your token, and then the exchange can transfer your token for you. And to be able to do that, you have to approve that the exchange can do that. And then also with a limit, so that it cannot transfer all your tokens, but only a certain amount of tokens. So that's all the functions there is to ERC20. Now, how do you make it? The most simple way to do it is go to a website like this. Somebody has just created an ERC20 generator. You fill in some values, you press on create token, and then you have your token. So, well, everybody now can create a token. It's pretty straightforward. But actually for us it's much more fun to go one level deeper how it works below this. I've made a couple of movies to do that, which you can click later on, and you can see all the interactions. But we can create an ERC20 token in the Play editor. If you will click on this link here, there's the source of an ERC20 contract. And what I've done, I've taken one of the ERC20 contracts which I found on the internet and made it as simple as possible. So deleted everything that's not absolutely necessary. And that way it's quite a small contract. So you can see actually most of the lines here. There's a few more lines above here. So it's about 63 lines of code. That's all there is to the smart contract. And then you can deploy it, and here in the constructor you have to give the name of the token and the symbol of the token and the number of decimals, which is 18. So you just deploy it. And the contract address is made, of course. And then you can query the information functions like this to get the decimals, the name, the symbol, and the total supply. In this example, the number of tokens is pre-programmed, but you can change that line, of course, and make it to another number of tokens if you want. Now we're going to use the domain functions. First I checked my own address, what's the balance of it. Now that's of course the entire thing. So that's, I think it was 10,000 tokens with 18 decimals, so that's a lot of zeros. And then you can transfer it. So here you put in another recipient, the amount, and you transfer it from the Play editor. Now, we're going to look at the central part of the contract, so we zoomed in a little bit. And there we have the transfer function, which transfers the tokens from one place to another. Oh yeah, what's important to know that the registration of the tokens, it's all done within a smart contract. So within that smart contract it knows which address has which token. So if you look at it from the other way around, if you are the owner of an address, of a wallet, and if you want to know if you have a token or not, basically you have to double check at different contracts and check all the contracts if you have a token or not. So that's not really straightforward. So of course you have well-known contracts with pretty well-known tokens. So the big wallets check those addresses. But for example, MetaMask, if you create a new token, then MetaMask does not know that token already. So you have to explain it to MetaMask. We're going to see that later. Okay, but coming back to the transfer function. First, there are a few checks. So that is not from a zero address or to a zero address, because then, yeah, that's not so much use to do that. And basically, there's just an array or a mapping which remembers which address has which number of tokens. So you just take the balance of the sender and lower that with a certain amount, and you take the address of the recipient and higher that, so you add that with a certain amount. So that's basically all there is, just to transfer some numbers. And oh yeah, by the way, this is an internal function. There's a function above it which verifies that you indeed have that number of tokens. So that's not in this function. Yeah, as I said before, in MetaMask does not really know that you have those tokens. So you have to tell MetaMask that you have the tokens, or at which place he has to look. So this is how you do that. In the MetaMask here you have a button called Add Token, and you go there and you say custom token, and then here at this field you can enter a contract address. So that's the address from Ethereum Play that you get. And once you enter it over here, you immediately see the token symbol and the number of decimals. So you see that it recognizes the contract. And when you say OK everything, then you finally see here in MetaMask how many tokens you have with the symbol that I just created. So now you can see it in MetaMask. But you do have to enter the address. If you have a big project and create a token that will be used by many people, you can ask MetaMask to build in your contract ID, but they have to allow that. So if we do it just here for our practice, then we're never going to get that address in MetaMask. But of course it's also cumbersome if every time you have to type in that contract address. So they've created also a function where you can, via your website, can also add it to MetaMask. And then not only add the contract address, but you can even also add an icon, so that it looks somewhat nicer in MetaMask. I've created a small example which you can click on here, and if you go that, and we'll show the source later on. If you do that, then you get a pop-up. If you want to add this token, and you see the symbol of the token here, and once you add it, then you see it in your account overview that you have that many tokens of that type that we created. And that's remembered in your MetaMask as long as your MetaMask is alive. If you reinstall it or whatever, it's gone. And you can also, if you press here, you can delete it again. So this is the piece of source that we use to add it to MetaMask. And that's yeah, it's done by this function, MetaMask watch asset. And there's a slightly complicated way to communicate with MetaMask, and it's using the async function. There should be another way, and I tried to do that, but it didn't work. So this one did work. So you can use this way to do that. So you call this function and with parameters, and the parameters I put over here. And they're basically all the information about your contract. So that's an ERC20 contract, the address of the contract, decimal symbols, I've got a double, and an image. So you can point to an image, which I put over here. So this is the very basic token icon.png, which I put in the same directory as the source. So it links to this file basically. And then that's this picture of this thing, and then you see it in MetaMask. So it's pretty straightforward to do. Well, this works in MetaMask, but you also have other wallets, and maybe some will support the same, but probably not all of them. So it's not a very general solution, but it's the best I know. Okay, well, we know now, we just saw the transfer function to transfer tokens, and because that's a standard function for all the contracts, it's built into other pieces of software. So it's also built in MetaMask. So within MetaMask you can transfer those tokens. So here I start with 10,000 tokens, and then I just take the screens that I would use to transfer some ETH, and instead of ETH you can transfer the token. So you click on the token here on send, you say to whom you want to send it, so the address of the recipient, you fill in all the fields, you confirm. So here I'm trying to send 5 of my tokens. Confirm it, wait a little bit, and then I see my balance here is a little bit lower. And if I select another account, and I also used the website before to make the token known, so that it knows the token, then you see that the 5 is over here. So the idea is that you're going to practice with it so that you get a feeling, but this is pretty straightforward. Now, of course, you can go to Etherscan and have a look what's going on. And you also can see over there that there's also 5 with lots of zeros being transferred. And if you verify your source on Etherscan, like that we did before, then Etherscan knows that this is a ERC20 contract, so it gives more information. So if you take this screen, then you see a lot of hexadecimal. And if you verified your contract with the green tick mark, then you see here at the event that it knows it's using the transfer function with all the parameters. So it has more information now. And there are other screens within Etherscan which are about tokens. So if you take this one, for example, you can see all the tokens transfers that everybody's doing. And you can see here that this token, the Web3 examples, bloody blasting, has been used for 5 tokens. And if you click some buttons, then you end up here. You see, for example, who are all the token holders. In this case, there's just 2 because I created them here and transferred it to one other. But this could be an entire list, and then you have everybody who is using that token. And even made a nice graph out of it. Now there's only 2, so it's not so interesting, but if you have more, then you get a nice diagram where your tokens are. Yeah, okay, so far we used a very simple version of the contract and used Ethereum Play to deploy it. But when you're going to do this for real, then you want verified, audited version of the smart contract. And what you can use then is the one of OpenZeppelin. OpenZeppelin, we saw that one before also with the upgradable contracts. And they sort of created a library with all kinds of contracts, and including smart contracts. You can just use that to deploy the ERC20 contracts and the other ones also. But they've made it a lot more complicated. So the version I had was about 36 line, 63 line. But their version is spread over a number of files with lots of comments, so that's quite large and more complicated to understand. So first you're going to install it with npm install. And then you can use Truffle as we did before, and you can use Truffle to deploy those contracts. And we have the two pieces. This is the JavaScript piece to deploy it. So this is a normal straightforward one to deploy the Solidity contract. And this is the Solidity contract. And that imports just the contracts from OpenZeppelin. So it has the ERC20 and the ERC20 detailed. In this case, with the details you can adjust it a little bit more. And then, hey, here we're going to call the constructor where we're going to create the smart contract with the parameters, just as we did at the play instance. And we're going to supply actually basically the same information. So that's the name of the token and the short version and the number of decimals. And we are going to say here how many tokens we have. So there's a function called mint, which creates the tokens. And in this case we are doing 10,000 tokens times 10 to the power number of decimals. So that's a one with lots of zeros. So you can change that in here. You can also later on call this function mint, so this is not a part of the ERC20 standard, but they've added it for, so that it can be used. So if you compile it and you check the directory tree, then you see there's a lot of JSON files, which corresponds to a lot of Solidity files. So the corresponding Solidity files are also on your hard disk after you've installed it, and you can look through them, or you can find them on the internet. But as you can see now, it's 7 files, so that's a bit larger. And one of the things it's including is a safe math library. And one of you already experienced something where you would need a safe math library, I think for sure. So who knows why a safe math library would be useful? Can you imagine what a safe math library would be doing?
Checking if it doesn't overflow the total amount of numbers the value can hold, so that you don't get a negative or return to 0.
Yeah, it checks for overflows and underflows and it protects it. So like for example the add, it checks that it doesn't overflow. Because if you, especially the underflow is interesting, if you have 0 tokens and you subtract one token, you would say I have -1 tokens. But as it's in uint, unsigned int, you don't have -1 tokens, but you have plus millions and millions and millions of tokens. So that's what you would never want with tokens, because then you would like a super billionaire if you would have that. So it's important, especially for tokens, to have some protection to prevent yourself from errors. So there's a couple of functions. It's, I think, add and subtract and multiply and div. And I think that's it. So also, if you need a save mod function, you can use it also from them. Okay, so this is the ERC20. Do you now think you can deploy one of those? Yeah. Cool.
I assume everything can be tested locally, right? Unit test.
Yeah. Even with an Ethereum Play, you can just easily do that. So you can do that in combination with Ganesh or whatever. So in a remix, so this one is pretty easy to test. Okay, now I have three contracts. I think I'm going to show the 777 one now, and then in the afternoon take the non-fungible, because non-fungible works slightly different. And 777 is also like the ERC20, so then you can try them both and see the difference. And the assignment is that you create both a fungible token and a non-fungible token. For the fungible token, you can choose the ERC20 and the ERC777. And where the S777 is more modern, of course, and the other one is easier to deploy.
Can your token subscribe to both ERC20 and ERC777? What happens then?
Yeah, you can combine them. They have.
Or do you get a power error or something?
No, you can combine them. I haven't really figured out how to do that, but it's possible to have one contract which is both ERC777 and ERC20. So if you want to make it difficult for yourself, then it's a good idea to try it. Okay, so we'll continue with the 777. So I've showed the functions again. So it's more or less the same. So we have the information functions at the beginning here. Then we have the basic interactions like balance and sending of tokens. They've added a function here to burn tokens. So who knows what a token burning is? Burning of a token?
From existence.
Yeah. So it's basically the reverse of the mint. With mint you get more tokens, and with burn you just remove them, delete them, so they no longer exist. So that could be useful to, sort of increase the price, like buying your own stock or something like that. Or if you don't no longer need them. You have a safe transfer function. So that's to add some security to the transfer. One of the problems of the ERC20 is if you transfer some token to a contract, and the contract doesn't know about those tokens, then the contract cannot do something with the tokens anymore. Because a wallet can call functions to transfer tokens, but contract itself, if it's not programmed to do that, it cannot call a transfer function to transfer the tokens again. So in practice, a lot of people have made mistakes and transferred tokens to a contract, and they're completely stuck now. So that's why they invented some security measures. It's also in the ERC 721, and it's also in this one. And then you have to call other functions to transfer your tokens. There's also a lot of functions to delegate the transfer of tokens. So you can use Exchange or whatever to do that. And to enable to do a safe transfer, you need on the receiving contract, you need a function so that that function can sort of accept that token. And if that function doesn't exist on the other side, you cannot transfer the token anyway. And if it does exist, it can accept those tokens. And for the ERC 777, that's this one, the token received function. And if you want to transfer the token to another contract and you want to call a function on the other contract, you want to verify if that function exists anyway. And to verify that, they've created this function, the support interface function. So we're going to explain it later, but this is the overview that we have. First, this one. This function is both in the 721 and the 777, and this function is used to verify if a smart contract contains a function or not, or multiple functions. If made some clever tricks to do that, as they often do, if it's not standard possible. And they've added a function called support interface. So you're using that function to verify which interface is supported. And suppose I want to verify if this function is supported and or this interface is supported, and this interface consists of two functions, function 1 and function 2, although I've written function 1. Then what they do is take the exclusive OR of the function of the 4 bytes of the function. So the 4 bytes are used to identify the function, and they're going to exclusive OR it, and then you get 4 bytes again. So if you call this function, the support interface, with those 4 bytes, and if you can get the answer true, then it supports those 2 functions, and if you get false, then it doesn't support it. Can you sort of imagine what's going on there? It's a little bit trickery. So each function has a 4-byte indicator. So if you have a simple one, it can also check if this function itself exists. So this one is a simple one. This has these 4 bytes as the function indicator. So if you call this function with these 4 bytes, then you're going to get the answer true. And the function, put the summary of the function over here. So it takes that parameter, so in this case it's this 4 bytes, and it checks a number of versions it had. So I've called this one I1. So it goes here, it looks here, while here I have I1, so I know that one, and then I'm going to return true. So I support this function. So you know that. And then if you want to check if this one is available, then this is two functions, so it's 2 times the 4 bytes. If you exclusive OR, do you know what exclusive OR is? I'm assuming that. It's one of the binary basic indicators. Anybody says, well, explain a little bit what is exclusive OR? No? If you take 4 bytes and 4 bytes exclusive OR, you get also 4 bytes, 4 different bytes. And the trick, the neat trick is that you can continue doing that. So you can exclusive OR 3 or 4 or 5 or any number of numbers, and you always get the same amount of bytes back, so always 4 bytes. So you can use the trick also with more functions. So here it just walks through here, and every time it finds one which it knows, then it returns true, and otherwise it returns false. And there's also one safeguard. If you do this with this identifier with all F's, then it's going to return false. That's just to as an extra safeguard for the case that somebody else has created a function like this supports interface, and it's very unlikely that it will behave exactly the same like this. So this is a sort of a sanity check of the function. So this way you can, if you're going to send a token to a contract, then you're going to call support interface, and then you're going to check if that contract is able to receive tokens. And if it's not capable to receive tokens, then you're going to revert it and get an error message. And if it is capable, then it's no problem. Now, for the ERC777, they have used yet another trick, because they thought, well, if you can do a safe transfer to a smart contract, why can't we do something similar when we want to transfer it to a normal address? Because the nice thing is, if you call a function where you transfer tokens, you can do some additional magic. Not only say that you want to receive it, but you can also do some calculations with it, or maybe send it further, or maybe give a signal to the end user or whatever. So they created a clever solution, if you transfer it to a normal address, that you can tell that accompanied to that normal address that you have to call another smart contract and a function to it. So I have a wallet here. And I want to send a token to it. So this is just a normal wallet, no smart contract, so that cannot receive any functions. But still I want to call a smart contract. So then I create another smart contract. And I want it to call this smart contract. But then of course, how does this contract know that these entities belong to one another? And to connect those two, they've created a registry. It's the 1820. And that basically connects those two. So here you have the UC77 contract. If it wants to transfer its token to this wallet, it first checks in this registry, does it know this wallet? And if it does, what's the corresponding smart contract? So it looks up this smart contract, and then it can call a function to this smart contract and check if it wants to receive tokens and it can do something with it. Is this clear what I've drawn? I also have it on slides. So this is a little bit rotated, but first I'm using the simple version where both the one who has the tokens and the one who's receiving the tokens are smart contracts. And this is the ERC777 contract. It looks up in the registry here, but for those it doesn't really have to, but it still checks it. And then before it transfers the tokens, it calls this function's tokens to send at this contract. So this contract can verify if it's willing to give up its tokens, or maybe it says I never want to give my tokens, never want to transfer it as a safety guard. And then it transfers the tokens and it calls this function in here. And if in this function you get an error message, then the whole operation is reverted again. So then the tokens are not transferred. And then if you compare that to the situation where the holder and the recipient are normal wallets, then you have here the connected contracts, which are connected via the registry. And then when you transfer the tokens which are from here to here, then those functions are called in this contract and in this contract. It's slightly complicated, but this can be used in more advanced use cases. Not really in our assignments, we're not really going to use it, but just that you know that it is possible to do that. Now, why do you have to know anything at all about the 1820 registry? Because suppose you want to do this on Ganache, on your local test machine, and then it's going to use that registry. What would happen? So I'm going to transfer my token contract wants to call the registry, and we're working on Ganache. When you start Ganache, what's on the blockchain? How many contracts are there on the blockchain already? It's pretty obvious, but still. With Ganache, yeah, you just start blank, then you start with nothing. So there are no smart contracts on the blockchain. So if you want to call the registry on Ganache, yeah, you can do that because it's not there. It's just empty. If you do it on any test network, they've deployed it on all the test networks, so you can do it over there. But on Ganache, it's not there yet. So they've created a small trick to deploy that registry on Ganache. So then you can use Ganache to test your smart contract. And to do that, you have to install this piece of software for OpenZeppelin. And then we are going to deploy it. We have a small piece of Solidity which is similar to the one before. Only the name of the function is different, of course, but you still have the name of the token and the short part of the token. And you're going to mint some tokens. But this part is a little bit different. This deployment on the smart contract, on the chain. So here we are requiring the helper thing we saw before. And what we're now going to do, we're going to deploy that registry. So it's just going to create that smart contract. So that's just calling this function, so it's not magic, but just calling this function. And then afterwards you can deploy the rest of the ERC 777 contracts. Yeah, once you deploy it and you look at the files, then you see there's even a larger number of files. So as you can imagine, this one is more complex than the other one. Yeah, and if you, I'm out of slides, but if you want to experiment with it and you are going to create something like this and receiving smart contract, then you have to use this example, the simple 777 recipient, and then you can see that that function is called when you transfer tokens, and then you can put something in a log file or something like that. So you get some extra information. So we're going to do that anyway with the 721, but you can also do that with this one. Okay, as you can see, this one is quite a bit more complicated. So if you know the ERC20 and you'll get familiar with it, it's probably the best way to start. And then later on you can go into the more complicated versions of it. And there are even a lot more versions of token contracts which are even more complicated than this one. So I'm not going into that, but if you're in future working on a real use case, maybe you will need a more advanced one. Okay, well this is for this morning, so you can now start practicing with it. And then the assignment is to create a smart contract, a token contract, and then put on GitHub where the contract is located. And also transfer a couple of tokens to my token address, so to my wallet. So in the end I should have a lot of tokens from each of you. So then I'll be rich. Okay, good luck. Okay, we're back again. Now we're going for the non-fungible tokens. In the meantime, I've received a couple of tokens from you guys, so I'm starting to get rich. Quite a few yet, so it's nice. I'm waiting for the rest, of course. Yes, now we're going for the non-fungible tokens. So that's the tokens which are sent individually. Now we have, like the previous ones, sort of a similar interface. Also the first information functions, name and symbol. We got the interactions, the transfer and the owner. You don't have a balance here because all tokens are considered individually. So you don't say I have 20 of those tokens, you have 20 separate tokens. So for each token you can double check who is the owner of the token. Now there's also the normal transfer from to transfer the token. And you have a safe version where the receiving contract can say that it is able to receive the tokens, just like the same as with the 777 contract. You have the delegation functions if you want to delegate. And here we have the function which is supposed to be on the receiving end of the contract. And I'll show that later on. And the call for to see which interface is supported. I've also made a couple of demo videos which you can look to double check how things work. I'm not going to show them. What I'm trying to show now is the contract itself. I've also made a relatively small non-fungible token contract based on I think the Open Zeppelin one, and I removed everything that's not absolutely necessary, but this one is quite a bit bigger than the ERC20 just because it's more complicated. You have to track each token individually, and they've created a slightly complicated data structure to be able to do that. So here you can see if you transfer a token from one address to another address, and in this contract they split it up in two parts: the add token to add a token to a new user, and the remove token to remove it from a user. And as you can see, the add token is already quite complicated because it's basically stored in a couple of locations, and the data structure we use here looks a bit like what I explained some time ago about the mapping and the array to track what's going on the mapping. So a similar data structure is used over here. I have a picture on the next slide to detail it even further. And you can see that adding the token is already complicated but straightforward, but removing it, there's a lot more code over there. So there's a lot of fiddling around with the arrays and shifting the arrays to be able to get the space free again. You don't really have to know the details, but that you sort of know what's going on. Yeah, when you create a token in this contract, this contract uses a counter to create tokens, and each token has a next number. So the first number has number 10, and then 11, 12, 13, etc. So that's done also on other contracts, but you can also choose other things as the token indicator. So you can also use a uint or whatever that's appropriate for your application. But this is a very straightforward one. When you create a token, it adds a token with the counter as parameter, and then it raises the counter to the higher number, so the next one has the next number. Now you can also do this one on Ethereum Play, and the more complicated one, you need Truffle to do that, but here you can interact with it on Play. You publish it again and you enter the token name and the short name for it. And, you don't have to specify any decimals or whatever, because each token is just done individually. And when it's published, you get an address. Now the simple functions are to check the name and the symbol of the address, symbol of the contract, and the administrator of the contract. So the administrator is the one who is responsible for the contract and can do more functions and change things in the contract. Now then when you want to create a token, first thing you do is call this function, create token, and you have to supply a minter, so that's normally your own address, who's responsible initially for that token. So you call that function, and then you can double check it, for example at the function total supply, and you can see how many tokens there are in total. So I did that right after I created it, and then of course the transaction wasn't processed yet, so it still showed 0, and then after a short while it shows 1, so there's now 1 token. And I can also look at the counter, because in this simple contract I've made all variables public, so you can interact with it and see what's going on. So you see it's 11 now, so that's the next one. Now the next thing what you can do with a token, a non-fungible token, that you can connect a URI to it. That's not absolutely necessary, but for interesting use cases that's usually done. And the URI you're adding is like a URL, but you can actually put anything you want in it. And what's frequently used is that you put a link to a JSON file. And the JSON file, here I've got a sample of a small JSON file. It looks like this. It's got some descriptions and those kinds of things. And the most interesting thing, it has an image. So you can point to an image, and that's the image of the token, and that's the thing that you can see in your browser. So MetaMask doesn't fully support that, but Opera, for example, does support that. You can see this token in Opera. And for example, in OpenSea, which we're going to see next, you can also see this picture. So if you want to make a game where this is used, like the crypto kitties, they use also a technique like this, and then each picture is a different crypto kitty. Or the crypto zombies, I think they also use the similar thing like this. Now, of course, you can look at each scan again, and you can see it also recognizes these types of contracts. So you can see that is a token transfer, and indeed with token ID 10 to my address. Now, first this one. You also have this display with the graphical overview of the token holders, just like the ERC20. Okay, then we are going to have a look at OpenSea. OpenSea is a marketplace where you can put your tokens and sell your tokens. So you can use a token for artwork, if you're a painter or a photographer or whatever. Then you can connect a token to your piece of art, and maybe put a small thumbnail picture connected to the token, and then you can put them on OpenSea, and you can actually sell them over there. So you can say, can give it a price, and then if somebody is willing to pay that price, he can just buy it from there. So if you want, you can put your own tokens that you're going to create. Not only if you want, you're supposed to put them on here, and you can put them on for sale if you want. So I have created a token and sent it to my own address, and then when I go to OpenSea, first you have to create an account, and then you can see with your account the tokens that you have. So initially I saw this, and you can see here the name of the Web3 example, blah blah blah. This is the name of the contract that I've given. And actually here you can see some previous tests that I've done, so there are some old tokens still there. And then you don't see the picture yet, and I think that's sort of a bug within OpenSea. If you click on this and go back again, then it looks like this, and then you do see the token. So it knows how to get the picture. So if you click on it, you come on this page, get to this page, and you see the picture here. And here you can see a user interface, and you can sell it or gift it. If you gift it, then you just transfer it to somebody else, so there's no problem. And if you sell it, you can set up a price, and if somebody is willing to pay that price, then they can get the token and transfer it. So you can sell your paintings, whatever. I'll hear a little bit about the data structure which is internal in the contract. As you can see, there are a couple of arrays within that contract, so that were the ones that were updated in the source code that you saw before. And it's structured in such a way that from every dimension you can quickly get access to the data that you want and update it. So for example, if you take one account here, then for one account you can see which tokens that account has. And of course one account can have multiple tokens, so they created a mapping to an array. So for one account you have an array with a number of tokens, so this account has these 2 tokens. You can also start from the other side. For example, if you know the token number, you can use this array and then look up this token number belongs to which account, and that you can look that up in this array basically. And they also have used a complete array of all tokens. So that's what you want to use if you want to get a list of all the tokens. If you would use it like this, then you can't get it because it's a mapping, and then you can't get every entry. And this is also mapping, so that's also not enough to get all the entries. So that's why they've added yet another array out of this, on this. And you can list the tokens. And they have added yet another mapping to this, and they use that too if you want to delete an item out of this. So imagine this array is maybe 100 items long, and you want to find the token which is place 100, then you would have to check all the entries in the array. So that's pretty slow and takes up a lot of gas. So with this index you can directly jump from the token ID that you have into this array and then clean it up. So this helps if you want to have a look at the contract and see what's going on. And of course finally there's a mapping from the token to the URIs. There you get all the JSON files. Yeah, and then the JSON is a separate data structure from JSON file to something like this, to a picture. And this is what it says in the standard, the 721 standard. So these are the basic types that you can add, and several applications have sort of extended that schema, because it's just JSON and you can just add whatever you want to it. So for example, OpenSea itself has added a number of extra things like an animation and a YouTube video that you can connect and a color and well, all kinds of weird things to make the user interface nicer. Okay, here we have the ERC165 again, which we also saw this morning. It's also used in here. And let's see to recognize the if the contract really supports the 721 interface. I've added, by the way, an example to see how the exclusive OR thingy works. So if you, for example, have this function and this function with this 4 byte and this 4 byte, and if you exclusive OR that, then you see a pattern like this. So it's a combination of these two. Yeah, now we're going to the receive part. So that's the security measure if you want to send a token to a contract. And then you want to make sure that the contract is able to receive the tokens and do something with it, display it on the screen or whatever. So to transfer the tokens you use the save transfer from. So the save is the important part. And the token contract then calls on the receiving contract this function. And yeah, a small side step which we're going to use in the next slide. To be able to recognize that function, it wants to know the 4 byte code of the function, and you can retrieve that if you take the string of the function with the parameters and put that in the function getCock and take the first 4 bytes out of this. So if you do this on the website and you copy paste the string, it calculates it and you take those 4 bytes and that's the same as those 4 bytes. So these 4 bytes we're going to use it on the next slide. Yeah, so this is a part of the contract which is over here, the NFT contract, and this is where you receive it. As you can see, this is the constant that we just calculated. We could, in theory, in the smart contract also calculate it, but it's also useful to do that beforehand. Why would you think it's useful to not calculate it in the contract, but do that before? Why would you do that? Very simple, but
to go to the solution multiple times. It's not only in the function itself, but you can use it in all.
Yeah, you can use it everywhere, and more important is that it doesn't cost any gas. If you do it in a smart contract, you have to pay gas for it, and yeah, that's sort of unnecessary because the answer is always the same. So you could just calculate it beforehand and then put it in the contract like this. So that's what they've done in that contract. Okay, the function on ERC 721 received has to look like this. It has to have this interface, but most important is that it returns the same signature, which is also the signature of the function itself, and it has to return it. That's just a safeguard to make sure that this function does what it is supposed to do. And then if you look at it from the other side, this if the token contract wants to call that function, Then you have the save transfer from function, and it checks a couple of things, and then finally it calls here the onReceived function in the other contract, and it uses a bit of assembly. Oh yeah, here it uses a bit of assembly to make sure if what you're calling is a contract anyway. So if you're calling a normal wallet address, then you don't have to do the check, and then you would get an error anyway. Here it's asking the size of the contract, and if the size is 0, then it's no contract. So in this case the size is larger than 0, so it's a contract. And then it's going to call this function, so this is the function from the slide before, and it checks the output of the function, and so it checks the signature, and only if that's the same then it's okay. Okay, I'll try to show this from Play how it works. So I have here 2 instances of the same contract. So I'm creating the contract here. Call this one left. So I'm working on ganache. This is a bit bigger. Call it right. Oh, my fence. There's a different address. Yeah, it's difficult to see. Okay, now I have 2 contracts. Now on this one I'm going first create a token. Copy my address. And now I'm going to send it to the other one using save transfer from. That's from myself. And then to, I'm going to use the contract address. And I'm going to send token 10. First. It's difficult to see. I'm going to refresh it. And deploy it again. Right. Show if on the here on the received function, I'm saving all the input parameters, so you can see later on what I've received. So for example, here received token ID that contains the token ID that I've received. So if I call that now, it says 0. So I've not received any token yet. Now I'm using this here to send the token to. So that's the other address. I'm sending it. And now I've used this. Yeah, I see that I've received this contract has received token number 10. And I received it from this address. So that's starting with 6D. So that's this address. Clear how this works? Yeah, sort of. Just to play with it a little bit. Yeah, so here it can be received it with this function in the other contract, and then we, in this case, we saved it in this global variable, public variables. But we can also do other things with it, calculate something, or say if we don't want it, for example, then we are not going to return this one, but we're going to return another value. Doesn't matter what value. But if we say return false or return 0 or whatever, then we don't receive the token. Now here is how you can do the same thing via truffle. You call this function with the name of the token and the short name of the token. Use this deployer function, so this is all pretty straightforward. And then as you can see in the resulting files, there's a lot of files that have been created, so that means that the source number of source files is also quite large. And these were the slides. So the idea is to, the assignment is to experiment with it and to create a non-fungible token and also show it on OpenSea, so that you can interact with OpenSea. So then you have to add a picture to it, so you can make a nice picture or whatever what you want. And you have to be on Rinkeby, otherwise OpenSea doesn't work. It only supports the Rinkeby network. And if you need any Rinkeby test, yeah, let me know. And also please transfer one of those valuable tokens to my account, and I'll be even richer. Okay, good luck.